When we hear about a photograph from the surface of another planet, the first thing that comes to mind is usually Mars. Of course, it's not surprising. We've been spoiled by photographs in recent years, but few people remember or even know that the first photograph in history from the surface of another planet was taken not on Mars, but on Venus. Half a century ago, the Soviet Union, practically blind, landed an umbrella on a planet whose conditions were practically unknown at that time. The end of the 1950s, the Soviet space program was experiencing an unprecedented boom. Triumphant missions were carried out literally every year during that period. The first artificial satellite, the first living creatures in space, the first flyby of the moon, and photographs of its dark side. After such successes, it seemed that nothing was impossible. So, when they started talking about the world's first landing on another planet, Soviet scientists and engineers happily agreed. Today, it sounds extremely utopian. In those years, absolutely nothing was known about other planets, which would be enough for such difficult missions. However, in August 1959, a meeting was held, and on December 10th, a government decree was issued on the creation of a station for a flight to Venus, and, at the same time, to Mars. And already at the end of 1960, these stations, which did not even exist yet, were supposed to be sent into space. Surprisingly, but then Soviet scientists seriously believed that Venus had an atmosphere similar to Earth's, as well as water and extraterrestrial life. To be fair, they weren't the only ones who thought so. NASA reports from that time also contained drawings of dinosaurs. That's why the Venera-1 mission was sent on a deliberate collision course with the surface of Venus, but it missed. Due to a loss of communication, the probe was unable to make corrections and flew past the planet by 100,000 kilometers in 1961. In cosmic terms, this isn't that far. No one in history has been so close to Venus. Then began a whole series of long-suffering, unsuccessful missions to conquer Venus. And it lasted exactly decades, almost in every launch window that opened as a result of the planet's approach. New Soviet research stations left for Venus, but for no less than a close idea of the real state of affairs on the planet, the probes did not have the slightest chance of reaching the surface. Venera-4, Venera-5, and Venera-6 were torn apart in the atmosphere by pressure, which they also had no idea about. The error was too great. What's good is that they all managed to transmit data to Earth about the composition of the atmosphere, its temperature and pressure. For example, it turned out that it consists of 90% carbon dioxide and also has sky-high pressure and temperature values. In a word, there was no talk of any life. Whoever was there, he was already incinerated by the sun's rays. It is also interesting that those who participated in the mission were very disappointed, and some even said that their lives were wasted because only this dream made them do science. From this point on, the Venera space program changes its goals. It was necessary to find out whether there had ever been life there at all. Success finally came during the Venera-7 mission, which was actually not the 7th but the 17th. It's just that in the Soviet Union they preferred not to report failures. After much scientific debate, engineers decided to play it safe and develop new descent vehicles capable of withstanding 180 atmospheres and 540 degrees for 90 minutes. Its body was made not of aluminum alloy, like the previous Veneras, but of titanium, which increased its strength and weight. Such a device weighed 500 kilograms. Because of this, they had to abandon the installation of some scientific instruments. In essence, its capabilities were limited, measuring temperature and pressure on the surface, surface-type analyzer, and a device for measuring maximum acceleration in the braking section. Venera-14 was launched from the Baikonur Cosmodrome on August 17, 1970. To be on the safe side, an identical station was launched 5 days later, but it didn't make it to Venus. The backup was unable to leave Earth's orbit due to an engine explosion, but the original reached the vicinity of Venus 120 days later, and on December 15th, it made the first soft landing in history on another planet. In fact, it looked like a miracle. After all, there were plenty of chances that something could go wrong throughout the entire mission. In the end, Venera-14 almost suffered the fate of its predecessors. Having already reached the target and entered the atmosphere, the device's parachute tore, and the module descended faster than it should have. Moreover, upon entering the atmosphere, the telemetry switch failed, as a result of which the only parameter that was transmitted to Earth during the entire descent and the spacecraft's stay on the surface was the ambient temperature. And only a late analysis of the data showed that for another 23 minutes after landing, the probe transmitted data directly from the planet's surface, but without a picture. After Venera-14, new generation spacecraft were sent to the planet Mentz, thanks to which it was possible to stake out the primacy in its study, including obtaining the first image from the surface, as well as an audio recording, which was made during the descent of the device. But first things first. The computer called Venera-14 consisted of an orbital module and a descent module. The descent module was hermetically sealed. It contained most of the instruments and electronic control. In total, 14 scientific instruments were installed on the station, in particular a mass spectrometer, a gas chromatograph, an optical spectrometer, a nephelometer, an X-ray fluorescence spectrometer, a moisture meter, a thunderstorm device, a camera, a seismometer, a device for collecting and analyzing soil. The instruments were designed to analyze the chemical composition, measure atmospheric parameters, study the spectrum of scattered sunlight, and record electrical discharges in the atmosphere during descent to the surface. Venera-14 was launched on November 4, 1981. It weighed 760 kilograms. Venera-14 was a copy of Venera-13 and was launched 5 days after it, 4 months after the launch. On March 5, 1982, the Venera-14 descent module separated from the orbital module and entered the atmosphere of Venus. After entering the atmosphere, the descent vehicle, enclosed in a durable spherical capsule 2.5 meters in diameter with an ablative coating, slowed down in the atmosphere at a speed of 11 kilometers per second to several hundred meters per second. Data was obtained that made it possible to establish the temperature and pressure at altitudes from 110 to 65 kilometers. When the speed decreased to 250 meters per second and the overload reached 2G, the parachute compartment cover was shot off and a parachute was released near the water. And then a ring pyrocord cut the capsule in half. Its upper part was moved to the side by this parachute, and the lower part was dropped under its own weight. Then, the braking parachute was released. It slowed the fall of the station. The main instruments for studying the atmosphere started working. At an altitude of about 40 kilometers, the braking parachute was jettisoned, and the descent module continued its descent, but with the help of an aerodynamic shield. The amount of various elements of isotopes of compounds including water vapor in the atmosphere of Venus, was determined. It was also established that 8% of all solar radiation is absorbed at an altitude of 60 kilometers, where the strongest wind blows. The structure of the clouds was recorded, and the illumination in their lower part was determined. The speed of the descent module when approaching the surface of Venus was 30 kilometers per hour. It was at this moment that the probe's microphones were turned on, where we can hear the only sound from the planet Venus to date. This is a mysterious hum. Amazing, isn't it? The umbrella is approaching the surface. To protect it from impact, a crushable annular shock absorber was installed on its underside. The Venera-14 lander landed in the Phoebe region, 950 kilometers southwest of the landing site of the Venera-13 lander. After landing, the Venera-14 lander transmitted a panoramic image of the surrounding landscape. Amazingly, these are the only photographs from the planet Venus to date. This is a mysterious hum. Amazing, isn't it? The umbrella is approaching the surface. To protect it from impact, a crushable annular shock absorber was installed on its underside. The Venera-14 lander landed in the Phoebe region, 950 kilometers southwest of the landing site of the Venera-13 lander. After landing, the Venera-14 lander transmitted a panoramic image of the surrounding landscape. Amazingly, these are the only photographs from the planet Venus to date. In conditions of extreme temperatures of 466 degrees Celsius, and a pressure of almost 100 bar on the surface of the planet. Then, the signal disappeared forever. It's hard to believe, but a total of 27 Soviet spacecraft were launched from Earth to Venus. The last one was Venera-14, after which a new space program, Vega, was launched. From 1984 to 1986, it successfully studied the Venusian atmosphere using a balloon and transmitted the most accurate data about the planet. But this is still very little. Until now, not all the substances that make up its cloud layer are unknown, as is the mechanism of their formation. A full-fledged interplanetary station in the atmosphere of Venus could collect such data. But this would be a very expensive pleasure. Therefore, for many years, Venus was practically forgotten by researchers. We know surprisingly little about Venus, so new missions will allow us to take a fresh look at the planet's atmosphere, consisting mainly of carbon dioxide, and study the surface right down to its core. And who knows, perhaps there was once life on the planet Venus.